Welcome back to another video with It's Dr. Dan, and today we're going to be looking at ions. So what are ions all about? We're going to be looking at something called cations and anions. Now, where do these come from? Well, if you remember from learning about the periodic table, one thing about it is that atoms are inherently neutral, meaning naturally they're found with an equal number of protons and electrons. However, some of them have the tendency to either gain or lose electrons in order to try to fulfill its octet rule, or maybe its duet rule for something like hydrogen. So one thing that we're going to be learning about is looking at cations. So to remember this terminology, cations, or if you think of a cat, it has paws and they are positive, right? So they're positive. Anions, or I think of onions, they are negative. They kind of make you cry a little bit when you smell them, right? So you have cations and anions. So ions in general, as a blanket term, right, is any type of charged particle. And this is from the gain or the loss of electrons. So we're going to be looking at both of these two different types of ions here to try to get an understanding of what they hold and how we can count our protons and electrons in this video. All right, let's go take a look at them. Cations are going to be the first ion that we are going to examine. So what is a cation? Well, cations are positive, meaning that they have a positive charge. So certain elements or certain atoms will have a tendency to want to lose an electron in order to help it be at a lower energy state, to be more relaxed. So if I have, let's say, lithium here, what I am showing is that we have lithium is losing one of its electrons. So notice how they are separated. And it's all written on the other side of this arrow here. So it's letting you know it's yielding, it's breaking apart. So when we are writing a charge, we are going to write this as a superscript. This is very similar to the idea of an exponent. So if you reviewed your mathematics, right, you have exponents. We will just put a plus or a minus, in this case, a plus, to show you the charge. This can be written as +1, which is just a plus like so. This is the same thing as saying where I have 1 plus like this. It can be written as 2 plus, 3 plus, 4 plus, and so forth. And it's all depending on the number of electrons that have been lost. So if I lost, let's say, 2 electrons, you would see this written as 2 plus. If I lost 3 electrons, you would see 3 plus written down in the statement. So lithium, though, it only loses 1. So what does this exactly represent? Why a plus? Why are we doing that? Well, the way to kind of imagine this is think of it in terms of scales. So when we are losing electrons, we are becoming more positive. So if you have your periodic table handy, and if not, that's okay. But trying to think about it, lithium, what atomic number does it have? Well, lithium has essentially a 3 as its atomic charge, atomic number. So that means it has 3 protons because it has an atomic number of 3. Now, naturally, being that they are inherently neutral, it will also have 3 electrons. Now, when this thing breaks down and loses an electron, well, that number is going to change as a result. We will still have our 3 protons. The number of protons never changes for any of the ions. The number of protons is what identifies these species. So lithium is lithium because of the 3 protons. So that does not ever change. Only the electrons. I can't say that enough. Only the electrons change. So once we lose that electron, notice how now there's only 2 electrons. And the other electron left the atom. And then it probably went to maybe go to another atom that needed it or something to create a bond. That's for another day, another lecture. So when that happens, notice how we have more positive, so think of scales. the positive side is going to be heavier weighted as a result, and it falls down, meaning it is overall more positive. So that's where this plus charge comes from, because we have 3 versus 2. So that's why we show this as lithium plus. So remember, cations are more positive. They are losing electrons, and they become positive as a result. You would think when you see the plus, that means that it gained electrons, but it's the opposite. It's all about scales. Think of the charge balance. So when we are trying to solve for ion charge, we can do simple calculations to check for ourselves. So the way that we can get that +1, it's a very simple calculation. We just take the number of protons, we subtract it from the number of electrons, so 3 minus 2. What do you get? You would get a +1 as your charge. So this is where that math is coming from, is protons minus electrons. And you can do this for any species. It's something that's a good one to have in the back of your notebook somewhere, and have it like boxed off to know how to calculate ionic charge. Let's look at anions. Anions are the same general idea, but it's going to be the opposite case, being that onions, think of how they make you cry, right? Meaning that we're going to be, in this case, gaining electrons, are becoming more negative as a result. So in this case, you can see that I have a neutral fluorine over here, and it is gaining 1 electron. Okay, so we're gaining. Therefore, it's making a ion, or an anion in this case. Notice how it is more negative. So how exactly does this work? Well, if you think of fluorine and we were to count all the little orbs it has, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That means it has 9 protons. And as it's neutral, it has 9 electrons. So if it gains 1 more electron, what's going to happen? The scales are going to be distorted, and the electrons are going to be more as a result. So we'll still have 9 protons, but now we're going to have a total of 10 electrons because we gained that 1 extra. So when we do that little simple math, we can see, okay, if we have 9 protons minus those 10 electrons, and we have a -1 charge as a result. So this is what an anion is all about. When you gain an electron, you become more negative, and it shows that, okay, you have more electrons than protons. Remember, every proton has a +1 charge. Every electron has a -1 charge. So we can see what is that balance. Let's take a look at some examples practicing counting our protons and electrons. So for our example for this video, we're going to be counting how many protons and electrons there are. This is what can allow you to actually be able to predict the charges, how to write them when you are to see them. So for example, if I were to ask you how many protons, how many electrons were for potassium with a +1 charge, how exactly would you do that? Well, first thing you have to identify is, what does a plus mean? And if you can remember from before, is a positive means that there's less electrons as our cation, right? It's positive, it has pause. So what you're going to have to do is go to a periodic table and find potassium. And what we can see is, okay, potassium is right over here, and it has a number of 19 as its atomic number. So what we'll do is we'll write that down. So we have 19 protons. So you just write a 19 with a P and then a plus that tells you protons. And being that we have 1 less electron, we will write 18 electrons to count that, okay? Because it's not neutral anymore, so they're not going to be equal. Now, what if I want to do strontium? Okay, so SR. So once again, we have to find SR on the periodic table. And you can see it's right near potassium, but it's on a different column here. So we have SR, and we're going to do the same general idea. It has an atomic number of 38. So our protons are equal to 38. Therefore, how many electrons do we have in this case? We have a 2+, so that means we have 2 less electrons. So it's going to be a total of 36 electrons. and that is where that 2+ charge comes from. Now with nitrogen, same idea. We go to our periodic table, we look what our number is. When we go through this, we're going to see that we have a total of 7 protons because it has an atomic number of 7. And then when you look up, so thinking, okay, I have a 3, and it's negative, so that means I have more electrons. So we can write down that we have 10 electrons for this particular ion. Well, in our last one, which is bromine, so with bromine, as we kind of, and I'll circle nitrogen as we went because I didn't go down to the periodic table. Bromine is down over here. It's number 35. So that means it has 35 protons. And being that's negative, it's more negative. So that means if we think of the scales, right, the 36 is a little bit lower. So that means that's 36 electrons when we think of the balance between the two. Now, how do you know where the ions are? The good news is many of the ions are considered to be predictable. So let's take a look at that. What exactly does that mean? The good news is many of the ions that you will come across in general chemistry or introductory chemistry are predictable, meaning that there is a trend essentially hidden in the periodic table, but it's not very hard to find. It has to actually do with the columns. So on the left-hand side of the periodic table and the right-hand side, the left is mainly all your metals. The right is all non-metals, meaning they have a tendency to what they actually want to do. Metals typically are willing to give up an electron, meaning they want to usually be a cation in 99% of cases in general chemistry. Non-metals tend to want to take an electron, and it all has to do with their octet rule and trying to get to 8 electrons, which is the primary objective for all these different species when they're bonding, which we'll talk about in other videos. So the easy way to see this is, okay, over here, so I have my first columns. The first column, number 1, the way to remember that is this is going to essentially, the whole column has a tendency to have a +1 charge. And one thing you're going to notice is it actually has to do with their valence electrons and how many they have. So one thing on their outermost layer, lithium, for example, has 1 valence electron, so it's willing to lose that 1 electron. Same with sodium and potassium. So all of them, that whole column, is going to be a +1. Okay, so being that that's blue, we can kind of try to highlight the entire column is going to be +1. Now, when it comes to the next one, which is +2, the next column, well, it's going to be the same general idea, right? This whole entire column is going to have a tendency to be +2. And that goes all the way down to the bottom too, even though I kind of stopped the highlighting. It's the whole column. All right, so that means every single element in that column has a tendency to want to lose 2 electrons in this case. So we have +1, +2, and it goes off your columns. Now, I wish that trend always continued. It's not always as simple, but we can kind of go over to the other side over here. Now, the noble gases, which is helium, neon, argon, krypton, these electrons are completely happy. They have all their electrons in their outermost layer. They do not want to lose. They don't want to gain. They do not react. They don't do anything. So the way to remember that one is, okay, these are just going to be a big fat 0. They're neutral. They don't want to do anything. Meaning that the next column, which is the halogens, so where fluorine is and chlorine and bromine, this is all going to be -1 in this case. So a 1- here. So this entire column is going to be 1-, okay? So all of that will be our first one, and we'll put that there. So as we move over, the next column will be 2-, and the one next to that will be 3-. So it keeps going, right? This has a tendency to want to take more and more electrons because the goal is to try to take all the electrons that it can to fill that outermost layer. So we have 2-, and we have 3-. Okay, so now we'll highlight this column in red and the next column in green. And the elements that I have written down are the ones that have the tendency to do these charges. So everything below it doesn't really have that charge tendency. It kind of ends at a specific point. So all these columns have this charge. Now, is that the only ones that have this charge? There are some other spots too. The first one is what I refer to as the steps over here. So the steps start at aluminum over here on the corner. So we have aluminum, then we have zinc, and then we have silver. The way to remember these is if you think of 1 step, 2 step, 3 step. The first step in this case is going to be this, silver in this case. So if we put a +1 charge, zinc will be the second one, which is +2. Aluminum will be the third step. So usually where I always start the steps is aluminum, being that it's kind of on that third column there. So it will help you kind of remember where the +3 generally starts. And then you're just walking down the steps as you go. So it goes 3, 2, 1. And now these are all the predictable charges that are always the same for ions. They always have this tendency to lose or gain electrons. So the right-hand side is your anions. The left-hand side is your cations. So you can kind of see metals, and then your non-metals have these general abilities here. Now, hopefully this video kind of helped you be able to understand and predict these different things. It'll be able to help you see exactly what the charges are on them all. There will be more videos that come with more on ions and different practice problems. So keep practicing, keep trying to understand these concepts. Let me know what you think, if whether it's in class or in the comment section or whoever's watching the videos. Thank you so much for watching. If you can like and comment, subscribe if you haven't. I appreciate all the support. Thank you all. Have a wonderful day.